Right, this is the fifth video that goes with Chapter 5 on radians, and this is the video that goes with Section 5.5, Small Angle Approximations. Now, we did say one of the uses of radians is when we're doing approximations, and approximations in mathematics are quite important. So, what I want you to do, you can see in front of you, you've got a table. You've got x that's measured in radians, quite important, and a column titled sin x, column cos x, and a column tan x. What I want you to do is I want you to stop the video, and I'd like you to fill in, using your calculator, your values for, say, for instance, sine of 2 radians, cos of 2 radians, tan of 2 radians. And when you've filled in the columns, I want you to see if you can see a link between the angle in radians and the value of the sine of the angle, cos of the angle, and tan of the angle. Okay, so make sure you stop the video, fill those in. Right, now I have now filled in those values, and if you see if you can spot a link between the value of the radian and the value of sin x, cos x, and tan x. What you should notice is that as the x value goes down the table, and you'll, as the x value gets smaller and smaller and smaller, closer to 0, there is a link between the x value and the value for sin x and tan x. In fact, as x tends to 0, you can see that the value of the radian, for instance here, and the value of sine are quite closely linked, and same for tan. Now, the one for cos is quite difficult to see, but here are the links. So, and this is right, if x is small, and we do mean very small, very close to 0, either negative or positive, but very close to 0, the following rules we can write down. So, and they're called the small angle approximation rules, or the small angle approximation formulae. So sin x is approximately x, tan x is approximately x, and you can see that that's true as you're going down. We're getting closer and closer and closer. Now, the one for cos is actually quite difficult to see. So the one for cos is cos x is approximately 1 minus x squared over 2. Now, these are in your formula book. You don't need to remember them, but you do need to know how to use them. And when we look at differentiating trig, we'll see the use of these again. So this is true again, but only in radians. It's actually quite important. So let's just have a little look at the graphs, and you can see, revealing the graphs there. Now, if your trig graphs are drawn in radians, you can see from the first one, from this one, we've got the sine wave, and if I superimpose on top of it y equals x, you can see when x is small, in other words round here, that sine x almost equals x. The same for the tan one. Okay, tan one there, when x is small. Okay, that also equals x. And this one, when cos is small and theta is small, you can see that the cos wave is almost the same as the graph of 1 minus theta squared over 2. So how can we use these? Well, let's have a little look at this question. So straight away, I'm going to have a little look. Now, if you remember, we said that sine x is approximately x if x is a small value in radians. And here in the question, I've got sine 4x. So therefore, sine 4x must be approximately the same as 4x. And also here we've got tan of 2x? Well, we know that tan of x is approximately x, so therefore tan of 2x will be approximately 2x. So we do some substitutions. So sine 4x becomes 4x, tan 2x becomes 2x, and we're dividing by 5x because 5x is 5x. So this gives me 4x minus 2x is 2x, 5x, and of course the x's will cancel. So the value of that is 2/5. Okay, so the important thing is x is small and x is measured in radians. If x is not measured in radians, we do have a bit of a problem. In fact, our approximation won't work. So number 2, okay, we've got cos of 4x. So again, we'll have a little look. We said that cos of x is approximately 1 minus x squared over 2. So cos of 4x, now you can see what's happened. We've replaced x by 4x. We have to be very, very careful. We're going to, wherever I see the letter an x, I'm going to replace it by 4x. And therefore, that will simplify. 4x all squared is 16x squared over 2. So that's 1 minus 8x squared. Now, this is quite important, this step, because this is where it's going to go wrong. Okay, so I'm going to do that in the context of the question. So this is cos of 4x. Well, we know that cos of 4x, if you look down here, you can replace that by 1 minus 8x squared, and then we've still got the minus 1 from here over x, and sine of 2x can be replaced by 2x. Let's sort that out. So on the top you've got minus 8x squared, because 1 minus 1, and on the bottom you've got 2x squared, and you can see that's going to end up as negative 4. And you can test this with your calculator. If you type in cos of 4x minus 1 over x sine 2x, and you substitute a value for x that is very small, and as long as you calculate it in radians, then you will get something that is close to negative 4. So let's have a look at this one. So it says, show that sine of 5x plus tan of 2x minus cos of 2x is the same as 2x squared plus 7x minus 1. Right, we're going to go straight for it. So sine of 5x needs replacing tan of 2x and cos of 2x. So I'm going to do left hand side. Left hand side is the sine of 5x plus the tan of 2x minus the cos of 2x. So sine of 5x, well, we know that sine of x is approximately x, so sine of 5x will be approximately 5x. And we also know that tan of 2x is approximately x, so, sorry, the tan of x is approximately x, so the tan of 2x can replace by just 2x. Now, this is the one that's the problem. Cos is always a problem, so it's minus. Okay, and it's 1 minus. Now remember that cos of x is approximately 1 minus x squared over 2. So we are replacing x by 2x. So I get 2x all squared over 2. We sort that out. 5x plus 2x is 7x. Then it's minus 1 minus 2x all squared is 4x squared over 2. The 2 and the 4 will cancel, so you end up with 7x minus bracket 1 minus 2x squared, 7x minus 1 plus 2x squared, so 2x squared plus 7x minus 1, and that equals the right hand side, which is right. So that's the sort of thing that we are going to be doing. Now, the one you have to be really, really careful of course, is the cos. And so be very, very careful when you're substituting that in. So let's look at an exam question. And this is the last one that we're going to do. So part A says, show that cos 3x sine 2x plus tan 4x is equal to 6x minus 9x cubed. Then it says, hence find an estimate for the cos of 0.15, sine of 0.1 plus tan of 0.2, and then calculate the percentage error. So if you don't know what percentage error is, I'm going to let you in on that little secret. If you do, that's absolutely fabulous. So I'm going to do part A first. So it's a show that, so I'm going to do left-hand side. And the left-hand side is cos of 3x sine of 2x plus the tan of 4x. Now the sine and the tan are easy substitutes. Cos is a little bit more difficult, and I'm going to write the cos one on the side here. Cos of x is approximately 1 minus x squared over 2. So this one is going to be 1 minus, no, it's 3x squared over 2 multiplied by 2x, because I'm replacing sine 2x by 2x, and the tan 4x is replaced by 4x, because tan x is approximately x, so tan of 4x is approximately 4x. Just need to do a little bit of sorting out. So inside this bracket I've got 1 minus, so 3x all squared is 9x squared, so that's 9x squared over 2 multiplied by 2x and then plus 4x. Multiply out or expand this bracket, so I get 2x minus 9x cubed plus 4x. Pull the x's together, simplify your x's, and you get 6x minus 9x cubed, which indeed does equal the right-hand side. Part B says, hence find an estimate. So we need to know what value for x we're going to substitute in. So if we compare part B, okay, we've got cos of 3x sine of 2x plus the tan 4x, and we're going to compare that with cos of 0.15 sine of 0.1 plus the tan of 0.2. Now let's do a little bit of comparison. You can see therefore that 3x must equal 0.15, or 2x must equal 0.1, or 4x must equal 0.2. Whatever you do, you can see 3x equals 0.15, therefore x must be 0.05. And we're going to sub that, into 6x minus 9x cubed, which is our approximation. If we pop that in, therefore 6 lots of 0.05 minus 9 lots of 0.05 cubed, that equals 0.298875, or 2,391 over 8,000, and that is our estimate. That is an estimate. Okay, an estimate for cos of 0.15, so cos 0.15 sine 0.1 plus tan 0.2 is approximately 0.298875, or 2,391 over 8,000. So I'm just going to highlight that. That is exact. And this is our approximate, or approximation, or our estimation, which is quite important for part C, because part C, if we go back up, part C says calculate the percentage error. Percentage error, see, the formula for percentage error is usually exact minus estimate divided by exact times by 100 to turn it into a percent. Now what you will find sometimes when you do exact minus estimate, if the estimate is bigger than the exact, you will get a negative value coming out. It's not a problem, we usually just quote it as positive. Okay, so our exact is cos 0.15 sine of 0.1 plus the tan of 0.2 divided by the exact, sorry, my apologies, let me just go back, minus the estimate, which is 0.298875, divided by the exact, which is cos 0.15 sine times the sine 0.1 plus the tan 0.2. Multiply the whole thing by 100, okay, and you end up with 0.845, and that is our percentage error. Oops. 2, 3 significant figures. And that finishes the videos for section 5.5, and in fact that finishes the videos for chapter 5.